Hello, this is Rikka, a learning guide for electrical workshops. Today's lesson covers the basic PLC time chart process. Understand the PLC ladder configuration and test through the simulator. Then, enter the corresponding PLC ladder into Arduino to see if it operates normally. On the right side of the screen, there are input-output parts for each PLC. There are 6 inputs and 5 outputs. Each configuration is described above. First of all, start each electrical connection of the LITSA simulator. Let's look at each configuration of the ladder through the PLC editor. PLC ladder configuration is explained. In the state of selector switch SSA, rising edge, it is self-maintained by internal relay M0. The self-maintenance state is cancelled by internal relay M3 or timer T0, B contact. When the user inputs SSA, timer T0 operates for 5 seconds. Below that is connected the internal relay M1 for the timer up to 3 seconds and the internal relay M2 for the duration of 1 to 5 seconds. Internal relay M1 is connected to lamp PLA and internal relay M2 is connected to lamp PLB. When the timer T0 reaches 5 seconds, the A contact of T0 is activated, and at this time, the self-maintenance state by SSA is cancelled. Therefore, all lamps PLA and PLB connected to M1 and M2 turn off. Now, let's take a look at the operation configuration by the selector switch SSB. It is connected to the internal relay M3 by the negative contact of the selector switch SSB and becomes self-maintained by M3. Here, the self-maintaining state can also be cancelled by the internal relay M0 and the B contact of the timer T1. Negative contact is a contact that operates by one pulse signal when returning after input. When the internal relay M3 is activated, the timer T1 starts operating and has a time of 5 seconds. Timer T1 is connected to M4 until 4 seconds and connected to M5 between 2 and 5 seconds. And each internal relay M4 is connected to lamp PLA and M5 is connected to lamp PLB. When the timer T1 reaches 5 seconds, the A contact of T1 is activated, and at this time, the self-maintenance state by SSB is released. Let's look at the internal relays M0 and M3. The M0 coil holds the selector switch SSA input status, and the M3 coil also holds the SSB input status. Therefore, the selector switches SSA and SSB have mutual first-in first-first interlock relationship. This means that if one action is started, another action cannot be started. And another action can be started when the first action configuration is finished. Finally, let's look at output configuration. Earlier we know that there are 2 lamps PLA, PLB. There are M1 and M2 controlled by SSA and M2 and M5 controlled by SSB. Each configuration is connected to each lamp PLA and PLB through logical inversion like the screen. Now, after explaining the PLC ladder, let's take a look at the operation configuration through the Rikka simulator. And finally, let's input it into Arduino and actually look at the result through processing.
Input on, wiring breaker. Input on, SSA. Input off, SSA. Input on, SSB. Input off, SSB. Input on, SSA. Input off, SSA. Input on. SSB. Input off. SSB. Input on. SSA. Input off. SSA. Input on. SSA. Input off. SSA. Input on. SSB. Input off. SSB. Input on. SSB. Input off. SSB. Input off. Wiring breaker.
World of Rikka. Thanks for watching. Please refer to learning. Subscribe check.